Okay, so now we're going to look at a system of nonlinear inequalities. So the idea is still the same. The graph is our answer, and so we've got to make sure that this graph is really, really precise. This is not a sketch. We need a good graph for this because the graph is the answer. Okay, so the idea is the same. We still need to get the picture, the boundaries on there, and we need to figure out the shading. Getting the boundaries on there is a little bit more difficult here because these graphs are going to be a little bit more complicated than lines. So we're looking at the boundary equations. Okay, so we want the boundary equations. We're looking at y plus x squared equals 1 and y equals x squared minus 1. Okay, now the second one should be familiar to you. What kind of equation is that? We've got y and we've got x squared. You should see that x squared and think quadratic, that's a parabola. If we get y by itself on the first one, let's move that x squared to the other side. You should recognize that now in this form is also a parabola. So if we see y and x squared, we know those are parabolas. Okay, so I'm just going to rewrite this one the same so we have them in the same spot. Okay, you should also have an idea of what these are going to look like. These are both parabolas. Okay, this one is a parabola shifted up 1, facing down. This one is a parabola shifted down 1, facing up. So for this section, the equations that you see here should be equations that you know how to graph based on the previous sections that we've had. You should be able to, in your head, picture the sketch of these. But remember, we're not sketching, we're getting a good graph of this. So we need a little bit more for this. What we really want to find first, before we try to put these onto the graph, are the intersection points. Okay, how do we get intersection points of two graphs? We do substitution or elimination. So this takes us back to all the stuff that we just did in 8.6. So we want to find the intersection of these two parabolas. So the first one is going to be a solid parabola and the second one is going to be a dashed parabola. We have an idea of what they're going to look like, and if we get the intersection points, then we should have this graph pretty quickly. Okay, so we've got y is equal to x squared minus 1 and y is equal to negative x squared plus 1 and x squared minus 1. So these are already set up to do a substitution. So let's just go ahead and do a substitution or elimination on this one would be fine. I already said substitution, so let's do that. Okay, so we've got negative x squared plus 1 equals x squared minus 1. Alright, so we see that this is a quadratic. We've got x squared and x squared. We could also think of this as getting to x squared, something squared is equal to a number. Either one of those would be fine. Let's go ahead and get everything on one side and see what we have. So let's move the x squareds over here where they're going to be positive because that always helps. And we see now we can get to x squared is equal to a number. So let's go ahead and move that number over there. There's a few different ways to solve these. If you see a different way, that's okay. So we've got 2 is equal to 2x squared. Let me bring that over here since we're running out of room. We're going to divide each side by 2. And we get x squared is equal to 1. We know that we can take the square root here. So plus or minus the square root. And we get plus or minus 1 is equal to x. Plus or minus 1 is equal to x. So remember, when we're finding intersection points, we have x, we need to find y. So we're going to plug 1 in, and we're going to plug negative 1 in. So if we plug them into the first one, we've got negative 1 squared plus 1. Now this negative is not inside the square. Remember, we talked about that before, order of operations. We're going to square it and then make it negative. So this is going to be 1 squared is 1. That's going to be negative 1 plus 1 is equal to 0. And for this one, when we plug in negative 1, this time the negative does go inside the square. We've got a negative inside the square and a negative outside the square. So this becomes positive 1, and then this one outside makes it negative 1 again. And we get 0 again. So the points that we get are 1, 0, and negative 1, 0. And just like before, we should check them. You can probably check these in your head. So just check the second equation. If we put in 1, we get 1 minus 1 is 0. That checks. If we put in negative 1, negative 1 squared is 1, minus 1 is 0. So we know that they both check. Okay, it's helpful to do that. You don't want to get thrown off on the wrong answers. So we know that the intersection points are 1, 0 and negative 1, 0. We also know that the first one is a solid parabola shifted up 1 facing down. Okay, so put the intersections together with what you know of the graph, and you should be able to put this onto the graph without plotting any points. So if we shift up 1, and we face down, and we go through these points, we've got a parabola that looks something like this. Okay, so there's our first one, our solid parabola that shifted up 1 facing down. Now our other one is a dashed parabola. It's shifted down 1 facing up, down 1 facing up, and we still have to go through, I'm going to put them in red. These are our intersection points right here. We have to pass through those. So sorry, I'm trying to get back to black. Okay, so so our second one is shifted down 1 facing up, so right here, and we've got to go through those intersection points. Ooh, I wobbled a little bit there, sorry, but you get the idea. And we're facing up like that. Okay, so that should be kind of what you had pictured from the beginning when we looked at these. We've got a shifted up 1 facing down, shifted down 1 facing up, and then we also went through our intersection points, so we can be sure that this is a really good picture of what's going on. Okay, so we got our boundary equations, we got our intersection points, and the intersection points are important anytime you're dealing with something nonlinear, because otherwise you're going to have to plot a lot of points to figure out what's going on. So even though it seems like a big extra step, it actually makes the graphing part much, much easier. Okay, so the last thing we have to do is figure out shading. Let me go ahead and erase some of this so we've got room for shading. Okay, so we've got our pictures up there. We know that this one is y less than, so we think we want to be below the solid one. And this one's y greater than means that we want to be above. So we want to be below the solid and above the dashed. Below the solid and above the dashed. That should be this area right here. We think that it's this area right here. Okay, but before you, I'm doing that so you can see what I'm pointing at. Before you actually shade it in, remember that you really want to test a point. So what point is in that region that we could test? Well, the origin is always easiest to test because zeros are great. Okay, so when we put zeros in here, we're going to have 0 plus 0 squared less than 1. That is true. Check it in the second one, put 0, 0 in here. We're going to have 0 greater than 0 squared minus 1. 0 greater than negative 1. Yes, that's also true. So we did pick the right region, and we can go ahead and shade that in. So we end up with this little hamburger right here. Okay, and that's the idea for nonlinear inequalities.